Hi guys, thanks for tuning in. My name is Bill at Beck Machine, and I wanted to kind of run through some of the modifications I've made on my Tormach lathe. The machine was purchased for two different categories of machining, one for standard production work and the other for gunsmithing work, and I made two major modifications to really facilitate that. So I'd like to kind of go through everything right now with you. First thing, I would recommend that you buy the touchscreen monitor. That's very handy. You can pick up the mini keyboard right here. It comes with the mouse kit. One thing that you really want is your jog shuttle controller right here. And this guy allows you to take manual cuts, move your carriage around very easily. It's you don't have to use a keyboard. You can just do everything right on the controller. And I also got the machine arm, and this allows you to pivot everything around, make it more convenient for you. Down below me here is the automatic oiler. I would suggest that you probably purchase that along with the rest of the machine. Alright guys, now we're on to the manifold assembly for the coolant. The front side is for workpiece coolant only, and it utilizes the pump that came with the lathe in the tank. The back side is for the barrel flushing head on the outboard side of the machine, and I have a motor with a gear pump hooked up to it, and I can deliver about 55 pounds at just about 4.5 gallons a minute coming through the bore. This side has a bypass assembly that's going back to the tank with a pressure gauge, so you can adjust the fluid going through the bore, and then the other side right here just goes out to the flushing head on the outboard side of the machine. Another needle valve right here for you to adjust coolant flow on the workpiece. Okay, so here's the tooling system that I'm utilizing currently. This is the multi-fix or multi-set Swiss style holders, and I got these from a guy over in Great Britain. They're a little bit more expensive than a Laura set would be, but they're well worth it. They're very, very repeatable, easily swapped out. I don't know if you can see the, there we go, I got a better view of it, but you can see all the little splines in there, and you basically rotate the tool holder around the tool post in 9-degree increments. These things are really worth the money, and if you really want to do accurate work, I would recommend that you pick them up and put them on the machine. Okay, now we moved up to the tailstock. This was the biggest, I'm not going to say problem, but the biggest issue that I had trying to use the machine for chamber reaming. The tailstock that you can purchase from Tormach is quite large, and it takes up a fair amount of room on this on the bed. And not only that, is as you're moving your carriage around and you're programming your machine, you really got to be careful what you're doing, otherwise you'll end up with a pretty good crash. The other thing I didn't like about it is every time you moved it, you had to re-indicate it in, and that was pretty much unacceptable. So what you're looking at right here is a tailstock off a flatbed lathe that's been inverted and mounted to a riser block assembly right here. I cut the tailstock in half, and then I cleaned this up cosmetically and put a little aluminum deal on here to make it look kind of professional, I guess. And then you're going to have to make your riser block. The center height is provided with the spec sheet, and that was kind of a challenge. I made a gauge on the Tormach to do that. It took a few passes on the mill, on and off the lathe, until I got the height right here. I got the center height right on. After that, it's pretty easily maneuvered into position for your quill. You extend that all the way out and put an indicator on it, and you can get it running perfectly parallel to the center and perfectly parallel on the center height. It's held at 4 different M8 cap screws right here that hold it in, and there's 3 M10s that are going through the center of the riser block itself. It does work very well. It's indicated dead on. I don't ever plan on taking it off unless I've got a work piece that's probably bigger than like 9 inches. You may have an interference problem between that and your chuck. Other than that, I don't have any issues with turning on 90% of the parts that I've done so far. Here a little bit now, you can see the piece of Lexan. Actually, there's two here that were mounted on the machine. Coolant control is a huge issue on the front. And if we drop the door, it actually fits right inside. It's pretty nice. You don't get a wet crotch anymore when you're standing by the machine. A couple bucks to put the Lexan pieces on. Okay, we're into the inboard spider assembly right here. And basically it's two parts, D14 back plate and a piece of stainless that I turned. There's a small flange on the outside of the back plate right here, and I got a pocket in there and slip the two together. It's a very, very tight fit, doesn't go anyplace. Standard 4-point brass tip screws on the spider. I don't seem to have any problem with deflection or inducing any barrel torque or none of that stuff that you kind of read online about. I can actually maneuver the outside here. The inside, basically, it's already from the outboard side by finger pressure when I'm dialing it in. So yeah, I know I'm not putting any stress on the barrel. Okay, now we moved over to the outboard side. I built the spider to slip over the collet closing indexing ring, which is right under here. And the idea behind that was to be able to remove the spider for doing production runs. That's a very tight fit on there. It's a little bit of an exercise to get it off. It's held down by 4 small metric screws on the indexing ring itself. And we got a standard 4-point system back here with brass tip screws as well. The machine has done a number of barrels now, and I always verify before and after the work, and never ever have had one move yet. This is my barrel flushing head that I actually manufacture these. Very easy to put on and off. Pull the screws, take them off, pop them back on, tighten it up. That's it. And it doesn't leak. I've tested this one up to about 55 pounds. I haven't had one issue with it. If you're interested in one of those, contact my good friend up in Fargo, Chris Harris at bulletcentral.com, and he will get you squared away and sell you one. The only issue I had with the machine was a little bit of axial run out on the collet closer indexing ring. And what I ended up doing was, obviously taking the shield off. There's a spacer right here, and the main drive pulley is right in this area right here. Get up a little bit so you can see that, sorry. And what I did is I took the drive pulley off, threw it in the ice, and I built a fixture for it, took a facing cut, and then I measured that on the axial side, and I had about 6 or 7 tenths. Put the spacer back on, did the same thing, measured it there, same amount, put the index finger back on, and that solved the problem I had with the vibration on the collet closer. About a couple hours worth of work, and got rid of that annoying vibration. Okay, now we moved around to the back side of the machine, and this is the gear pump and the motor and the oil filter that I purchased. Basically, the suction side of the pump has got a strainer in the tank. It was actually for a hydraulic oil pump. Discharge of the pump goes through the Fram oil filter, and then it heads back up into the flushing manifold that we saw earlier. That's a little noisy, and it's kind of in a temporary spot right now. I'm just trying to verify how long the Fram oil filter is going to last before I actually mount it to the back side of the machine. It does work good though. It certainly sends a high volume of fluid through the bore. And here we can get a good shot of the actual tailstock that you can purchase at Tormach. You can see how big it is, and it's very, very hard to move. It does function once you get it mounted on there, but as I stated before, it's just every time you move it, you got to redial it in, and it's just a royal pain in the butt to do that. That's why I went to the other system, and here was the Generation 1 tailstock. This was a used one that I got. And basically took a facing cut on the top, drilled the mounting holes, and then machined off everything else at the back side. This one worked really good, but it came off of a used trade school machine, so I wanted to purchase a new one before I finally started doing the barrels. Alright guys, that's all the modifications I've done. Hope you enjoyed my short video here, and we'll be making another one shortly on cutting the back tenon. on the Tormach CNC, and that will be followed by another video of the actual chambering process. So thanks for tuning in. I appreciate it.